Students have adapted extremely well to this mechanistic organization. It wasn't obvious to me at the beginning of my career, but over the years I've come to realize that one of the greatest motivations for students is the feeling that they understand and have command over the material itself. There is a hydrogen. I need to go find the hydrogen that's on a carbon adjacent to the one with the leaving group so that I can form that double bond that we know is going to exist in the product of an E2 reaction. So how do I do the curved arrows? How many? Three curved arrows. From where to where?
From the oxygen to the hydrogen.
So I want to think again about electron rich, electron poor. Which arrow do I want to draw in first?
From the top.
Okay, yeah. From there to the hydrogen.
From the hydrogen bond to the carbon.
Okay.
And then from the carbon bond to the carbon.
All right, so that leaving group's going to come off, and I'm going to have new double bond formed. The bromine has come off as Br minus. And what else has been produced? Okay. Because this mechanistic organization gives students a solid foundation for elementary steps and mechanisms before diving into complex reactions, students maintain that feeling that they are really in control of their own learning. And with that, students more naturally see and believe that really the more effort they put in, the more they get out. So students remain more highly motivated to do all of those things that as an instructor you want them to do. Read the book, study mechanisms, work extra problems, and so on. As an outcome of those things, one of the biggest differences the mechanistic organization has brought about in my class is in the questions that students ask. For one, they ask a lot more questions.
So the question asks, in which one would the HO minus act as a base in the rate determining step? And so in this one down here, I thought the rate determining step would be the first thing that happens. Doesn't the HO minus happen in the second step?
It does, right?
So that only has to do with the rate determining step. It doesn't have to deal with the second step in like an E1 or an SN1.
Absolutely.
It doesn't have to deal with the fast steps.
Right. I think the reason is that students become accustomed to the fact that things should make sense. And when something doesn't make sense, when they realize that they don't understand something, they ask. In addition, there's a difference in the kinds of questions that students ask. Rather than the what, students tend to want to know more about the how and the why of each reaction. Some of these questions are extremely good ones I would never have dreamed that students would ever want to know about, such as, why is that step reversible? Or one of my favorites, why does that alkylation of ammonia go to the charged quaternary ion instead of stopping at the uncharged tertiary amine? Really, these kinds of questions are much more refreshing than questions like, is that going to be on the test?